Okay, so the next question we'll look at is question 5.4, and the first part is looking at the formation of methane. So methane formation is actually quite difficult to do synthetically, as you can imagine. It's very difficult to isolate this anion. It's very difficult to have protons flying around, in essence. So the reaction itself is quite difficult to do experimentally. However, there have been attempts, but this is the typical thing that you would use computational chemistry for, to model, to look at something that is experimentally quite difficult, to look at its energetics, interesting facts, whatnot. And that is exactly what I want you to do. So my hint that I will give you, I will speak about this in general, I would go about this thermodynamically, meaning that I would look at the energy of this anion, energy of this proton, which I give you as, you can accept that as 0. You don't have to worry about the energy there. And then you look at the energy of methane on its own. But what energy? And that is where you need to remember it's Gibbs free energy that you need to look at. Not necessarily, you can also look at the enthalpy, but Gibbs free energy in general, in terms of reactions, spontaneity gives you an indication of whether or not a reaction will take place. So and then if you look at it, so which side is lower in energy, then that's the side that the product is going to form, right? So if this side was the lowest in energy, we would never have methane ever on Earth, and all methane would decompose to protons and this anion. But we know that's not true, so that is why mostly this is a very energetically favored process. So I would look at it as the sum, so you need to see it still as the sum. So you take this Gibbs free energy, you take that Gibbs free energy, sum it together, but this one is 0, so it's just the sum of that one. Compare it to that of CH4, and there you have your answer, whether or not the reaction will take place, and what is the formation energy, because that's technically what I asked, but that can be interpreted. The formation energy is the same as the energy released, or the activation energy, basically, etc., that kind of thing, and also asking stability. So remember, formation energy would be the difference between the two energies, and then you just need to make sure that this is actually the direction of the arrow. No, who knows? Maybe the arrow points that way. And then any discrepancies that you see, you need to discuss in terms of molecular mechanics versus the higher forms of theory that I list, or the calculation I give you there as a literature. Okay, that's all for this short question. And we're going to use this information in the next part of the same question. So the rest of 5.5 and how to do reaction modeling. So remember this process of summing two different things, comparing it to the product.